And then I will start sharing. PyCharm, and also I need to share Google Chrome. Okay. Hopefully the rest will join us shortly. Switching the lectures for this week in order should be no significant difference, except that you will actually be prepared for lab tomorrow this week. I talked last week about for loops, and we will review those. And they're the focus of homework 3, which is out. But the next lab is going to focus on while loops. So when you get into lab, into your discussion section tomorrow, there's a presumption that you've already talked about while loops. So my plan had been to go more into for loops today and cover while loops on Wednesday. I'm just going to flip those. I'm going to cover while loops today and a little bit more on fors. And then we'll finish up loops next lecture on Wednesday, and that'll be everything for exam 1, and we'll talk more about that. A couple of administrative notes. Again, homework 2, if you have not submitted it, is due tonight at midnight. Please make sure you get it in. Please submit if you're planning on waiting until the last minute. If you're planning on waiting until 11:59 to submit, please submit something about a half hour earlier, so just so that if your internet connection goes down, it's not a big problem. Little problems are easier than big ones. Homework 3 is out. It's due next Monday, the 1st. I will post the academic integrity quiz on Blackboard later this week because we have to have you do that before the exam. The academic integrity quiz is 10 true, false, or multiple choice questions along the lines of true or false. If you're having problems with the test, if you're having problems with a problem on the test, you can post the problem on an outside source like Stack Exchange, Stack Overflow, or Chegg and get help. And obviously the answer to that is false. You can't do that. But that's the kind of thing an academic integrity quiz is about. It shouldn't take you more than a couple of minutes, and that'll be out later this week, as will the sample exam. It turned out I was going to give you the sample exams from last year just so you can get a little look at the test. But Blackboard they were on Blackboard, and Blackboard, which I don't like, is making it very hard for me to find them and share them with this semester's class. So I'll get that worked out. There will be a real sample exam by later this week, along with the academic integrity quiz. Should be no problem. Okay. And again, as I said, today's lecture was actually going to be Wednesday on while loops, but it turns out the next lab is about this, so you'll be ready for tomorrow. So let's get going. A quick side note, you've seen something to explain because I haven't yet. We're actually prepping you for what's coming after the first exam. In most programming languages, you break up a program, a big problem, into parts, and you solve it a little piece at a time. And in Python, you do that with something called functions. Functions in method, but largely functions. And as I said, we'll get to functions after the first exam. Don't worry about them now. But how you structure your Python code is to identify what is the main program and what is a function. And the way we do that in Python 3, the version of Python we're using now, is with this statement right here, which is what we ask you to put in your homework and your labs. If blank space, and then these are 2 underscores together. If underscore underscore name underscore underscore equals, and this is 2 equals, so we're comparing to see if it's the same, and then a string. Inside the single quotes is the string we're looking to match to, and that's, again, double underscores. Underscore, underscore, main, underscore, underscore. Okay. Colon, and we ask you to put that at the top of your program, after your header comment block, but before any of your code. And then your code goes underneath it, and then you indent it 1 space. Now, Spoiler alert, this is got to become more important after the first exam. We get to the functions, but we want to introduce it to you now. This is how you tell Python what is the main program and what is a function. Anything that comes under here, anything that's indented under here, Python will treat as the main program. And it will only execute this as the main program. Anything that winds up being above this, coming before this, or not being part of this, Python is going to treat as a function. And that's going to have some implications on how your code runs and what it runs. And as I said, that's something that comes along after exam 1 in our class. It comes before exam 1 for the majors, which is why you have to start putting it in your labs and your homeworks. For now, just put it in and we'll deal with it. Here, the double underscore name, double underscore, is essentially a system variable. This is a variable that Python 3, not earlier versions, but Python 3, automatically defines for all programs. This is a variable that is associated with your program when it's running. Python understands it. The reason for this double underscore, double underscore, double underscore, double underscore is so you will not accidentally assign it to something else. I mean, you're writing your program, right? You're going to make up variable names. You're going to make up constant names. You're going to make up whatever names. Okay. You might accidentally choose this system variable and cause a problem, cause your program to not work right and not understand why it doesn't work right. It doesn't work right because you accidentally reuse this for something else. Well, 99.99999% of all programmers are never going to accidentally, randomly choose a variable name of underscore, underscore, name, underscore, underscore. So it has this bizarre form factor to make it incredibly unlikely that you accidentally pick the same name, assign it some other value, and cause the program to work in really wonky ways. That's why. This is a system variable that the Python defines, and they want to make sure you don't accidentally overwrite it, and so that's why they give this bizarre name. Similar over here, the underscore, underscore, main, underscore, underscore, is to make it incredibly unlikely you accidentally assign something else that matches. You're not going to use this in all likelihood. I mean, let's be honest here. If I ask you to randomly come up with a string, you're not going to come up with that one as your random string. You might put one underscore before and one underscore after, but you're not going to put both. So this is just a system variable and a specific value that tells Python 3 that this is the main program. What comes after this is the main program. And what's not after this is functions. And we're not doing functions till after exam 1. So this is a little bit of a spoiler alert. This is a little bit of a head. For now, just use it. Make sure you indent after it. And we're good to go. But that's what we ask you to do. That's why we want you to do this, is to get in the habit so that after exam 1, when we write functions, you'll already have this and we won't have to remind you to put it in there. And it's introduced now in labs and homeworks because the majors sections take their first exam later than we do, so they have to worry about this on exam 1 and we don't. That's what it is. So for now, just do it. This is why we ask you to do it. It'll make way more sense in about 3 or 4 weeks. Okay. So that's the explanation of why we're doing this and why we have you to do this. This is just a statement that tells Python what we're doing. Very quick review. For loops, last Wednesday's lecture. There are 2 types of for loops, for each and for I. For each is really a special case. So a for each loop is a special case when you want to do something with every element in a list exactly one time. You want to print each element exactly once. You want to go through the list, check each element to see if it ends with an A, and then do something if it ends with an A. You want to go through the list of integers and multiply each element by 6. You want to do whatever. It depends on what type it is and what your program does, right? But a for each loop is a special case where you want to take a list, you want to go through it element by element in order, and you want to do something with each element exactly once. Now, that happens often enough in programming that Python said we will define this for each loop as a special case. It's a little bit easier. The syntax is a little bit more straightforward. You can do this. And again, the limit is you don't want to change the element values themselves, because you cannot change the element values in a for each loop. You cannot do something like check to see if the element ends in A and change that last letter A to an E. Not allowed. So the first thing we covered last week is the special case of a for each loop when you want to do this one specific thing, and Python makes it a little bit nicer, a little bit easier for you. The more general case when you want to do something with a for loop is called the for I. And I is called for I because there's an iterator variable. I is the first letter of iterator, and quite often, yeah, you use I as the iterator value. You use I in range, whatever. And the for I loop has for, an iterator, a range to control the movement through the loop in the list. You do not have to go through every element in the list. You could go through multiple times. You could go forward through the list. You could go backward through the list. You can go part way through the list. You could go from 10 to 20 or 10 to 19, I think is the example we did last Wednesday. Okay, so you can just go through some or all or part or whatever of the list with a for I. And you can change values of the elements. You can, change Alabama to Puerto Rico. You can change Alaska to Manitoba. Okay. I had a friend who used to live in Minnesota, in Duluth, Minnesota, which is way up there. And my friend Earl used to refer to Minnesota as Baja Manitoba, Lower Manitoba. So you want to change the name of Minnesota to Baja Manitoba? You're cool. You could do that with a for I loop. Okay, it's a more general case. Now, we're going to get some examples later on, but I want to move, after having reviewed the things we did last time, to the most general type of loop of all in Python. The most general type of loop you can have is a while loop, and that's what we're going to cover today because that's what's on your lab. Now, this statement is very important. This statement shows up on tests a lot in some form or another. It is a fact in Python that everything you can do with a for loop, you can do with a while loop. Everything you can do with a for loop, for I, for each, either one, you can do with a while loop. The code may be a little more ugly, but you can do it. The opposite is not true. So when we say that a while loop is the most general type of loop in Python, what we mean is if you can do it with a for loop, you can do it with a while loop. But there are some things, and we'll get to an example in a minute, that you cannot do with a for loop that you can do with a while. However, with power comes risk. With great power, to whom the power is given, much responsibility is expected. While loops are the easiest type of loop to make mistakes in, and we're not talking syntax errors here. We're talking really fatal semantic errors that'll cause your program to not do what you want. It is very easy in a while loop to get infinite loops. We'll explain what that means. That is a loop that never ends. It has to have some outside interference to stop it. Okay. For loops, it is theoretically possible to create an infinite loop, but you really gotta want it. You really gotta try. Programming errors don't cause infinite loops with fors. You gotta want to do it. While loops, it's real easy to make that mistake. So, more power, more risk. We use while loops when we need to. A general statement When you know how many times you want to do something, you use a for loop. We want to do this one time for every element in the list, for each. Clarifying that. We want to do something the number of times the value of a variable, the number of elements in the list, 10 elements, whatever. If you know roughly how many times you want to do something, it's a for loop. If you don't know how many times you want to do it, it's a while loop. And let me explain that, and this is an example. Okay, so what I'm going to do is ask a user, and I'm going to copy and paste. This is in the code, which I'll share. I am going to ask the user to input his or her age. And when this user finishes inputting their age, we will check to see if it's less than 18. We need you to enter an age that's less than 18. So here is the syntax of a while loop. The word while. Now, PyCharm is very nice. It bolds this for me because this is a reserved word. The reserved word while means this is a while loop. Now, next comes a Boolean condition, something that evaluates to true or false. In this case, I've used age less than 18. Age is an integer. I can check to see whether or not it's less than 18. So that is a Boolean condition. Then a colon, and let's undo that. Okay. Then a colon, while, Boolean condition, colon, and then indented something in a loop. In this case, what I'm going to do in the loop is I'm going to ask the user to input your age in years. I just want an integer. Don't give me 18 years, 3 months, 3 months, 7 days. I just want your age in years. And if the user's 18 or over, I'm going to say, if you're 18 or older, you should vote. Now, here's the deal. I'm going to say, if your age is less than 18, I'm going to keep prompting. I don't accept ages of less than 18. You're all college students. Now, here's how this works. Enter your age in years. 4. Boolean. Is 4 less than 18? Yes, 4 is less than 18. That's true. Keep executing. As long as this Boolean condition right here is true, we're going to execute what's in the loop again. Enter your age in years. 8. Execute the loop again. -8. Perfectly valid integer, less than 18. 22. There you go. That's the end of our story. Okay. So syntax of a while loop. Okay. Syntax of a while loop is while some Boolean condition is true, colon, or some Boolean condition, colon. If this Boolean condition evaluates to true, execute whatever's in this loop. This statement is here unindented to show you that this statement is not part of the loop. This statement only gets executed when the loop ends. Now, point number 1, general while loops, not for loops. There is no way I could do this with a for loop using the Python techniques we're teaching. If you are a real Python hawk, you can actually cheat and do this with a for loop. But for the way we're teaching, you can't do this with a for loop. Why? Because you don't know how long it's going to run. How many times am I going to enter an age that's less than 18? 1 time? 30 times? Until I get bored? I've been known to play computer games for 4 or 5 hours at a shot. This is a silly game, but hey, I'll play your silly game. 4 or 5 hours, I'll keep putting in numbers that are less than 18. We don't know how many times this loop's going to execute. We don't know how many times this is going to be true. Since we don't know how many times it's going to be true, it's going to be true until I break down and enter a number that's actually greater than or equal to 18. Since we don't know how many that is, we have to use a while. A while loop works for loops when we don't know how many times it's going to execute. You can't do that easily with a for. Okay. Now, what if I left out this statement, age equals 0? Okay. And I just did this. Let's kill that. Let's get a new Python console. I have to get rid of the age bit, or this live demo will, as most live demos do, fail. Here, this fails because age is not defined. It has no value. Okay? Start executing here while age is less than 18. Well, what the heck is age? I've never seen age before. Age is a new entry in the symbol table. I grab a new location in memory. It has no value. I don't even know that age is an integer. I don't know that this is a valid comparison. Even if it is a valid comparison, I have no value, so I have no idea if this is true or false. So this is not defined. Now, you don't need that with a for loop, right? With a for loop, we immediately have a value assigned. For age in range 18, print line, comma, age. I didn't have to assign a value in my for loop. The syntax and the semantics of a for loop, what it means is that with a for loop, the value of age was automatically set. In this case, it defaulted to 0 to start. And so now I can execute. Okay. A while loop is not like a for loop. There is no predefined value for any variable used in this Boolean. There are no predefined values. You must explicitly assign a value. If you're using a variable in this while loop, you must assign a value to start, or your code fails, as we saw when I ran this code, without assigning age an initial value. So you must assign an initial value with a while loop. Okay? Oh, age got assigned from 4. And again, a demo fails. The reason this didn't fail like it was supposed to is age had a value for that for loop I wrote. There we go. But this fails if you don't assign an initial value. Otherwise, there's nothing to do. The example I gave here that I worked was the first while loop example I had. Is I assigned the value. And in that case, I didn't copy age. There we go. Okay. In this case, I assigned the value. Now, maybe I don't want to assign an initial value. Maybe I want to read in. So the terminology we use with while loops is a priming read. A priming read. If you go back to the olden days, the old joke of back in my day, I had to walk 5 miles to school each way uphill in the snow in South Louisiana and fly. There's absurd stories of how hard I had it compared to you, right? Back in the day, we had a pump and we had to prime the pump or it didn't work. So the term prime is like priming a prompt. Prime means get an initial value. A priming read gets an initial value. So this statement before the loop is a priming read. So the first example where I assigned age the value 0, that was not a priming read. That was just I assign a value to start with. This is called a priming read. I ask the user for a value before I get into the loop. Now, the key to this is 22. Notice if the user enters a value that's greater than 18, this loop never got executed. This statement never got printed. This loop never got executed. I went straight here because the first time through the loop, age was 22. 22 is not less than 18. The Boolean condition is false. Therefore, we do not execute the loop. So, difference between a priming read like this and an assignment is the loop may never be executed. I'll clean that up before I post it on GitHub. With a priming read, when I do the code this way, because I assign age the value 0, that makes this Boolean true. Writing the code this way guarantees that this loop is going to be executed at least once. Using a priming read means that there is a chance if the user enters the right value the first time, the loop may never be executed. But that may be what you want. That may, I mean, you know, why, if the user's going to enter an invalid value, a really bad value, why execute a loop that prints out an error message? You don't want it. You don't need to. So we use a priming read when we're getting a value, and if the user enters a good value the first time, we don't need to execute the loop at all. Now, those are cases where we're showing the basic syntax of a while loop that cannot be easily implemented as a for loop. I had a student last spring who was a chemical engineering major, whose boyfriend was a comp sci senior who sat in my class a lot. And he always took this as a challenge to figure out some way to write a Python code that would make that work with a for loop. Yeah, okay, please don't do that. It's not the point. The point is, the way we're teaching this, for loop isn't going to work. That's a while loop. Okay, this is one that never executes. Now, there are other ways to do it. Let's compute factorial. Okay. Factorial for an integer that's greater than or equal to 0. Well, 0 factorial is defined to be 1, so let's not go there. For any number factorial, it's just the product of all the numbers from 1 to that. So 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. 6 factorial is 1 times 2 times 3 times 4 times 5 times 6, which is 720, and so on. So let's compute 10 factorial using a for loop and a while loop to show that they're equivalent. We can write this using a for loop. So for I in range 1, 10. Now, why did I say 1 for my for loop? Because I'm going to multiply and I don't want 0. If I multiply by 0, that causes the code to be wrong. Okay. And I need something else. Factorial, we're going to initially start at 1. For I in range 1 to 10, factorial times equal I. That's all the loop I need. Print factorial. Now there's one thing somebody, let's see. Let's make sure, see who's posting things. Nobody posted things in the chat. You didn't catch me. This is not going to compute 10 factorial. This is going to compute 9 factorial because it's not actually going to execute when I is 10. So I need to stop at 11. So this will compute 10 factorial. Start at 1, multiply times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 do not work when I is 11. And there is 10 factorial. 3,628,800. That's the for loop. Let's do the same thing with a while loop. Now, instead of defining factorial, I'll define product. Same thing. Start with 1. We need our product, our factorial, to be 1. Now, I need, since I can't have an iterator automatically defined in a for loop, I need to have the thing I'm going to multiply, the factor, initialized to some value. I'm not going to read it in. It's not a primary read. I'm just going to assign it 1. While, now my Boolean is going to be factor less than 11 product plus times equals factor. Now here in the for loop, factor I was automatically incremented for me, right? In the for loop, this is automatically incremented by 1 every time because I left the hop count blank, so the hop count defaults to 1. So the for loop, this was incremented for me. In a while loop, nothing is incremented automatically. I'm going to have to say factor plus equals 1. Now I can say print factorial product. This is, I'll use the code I used, the variable I used in the actual code, and it works. So equivalent code, this computes factorial with a for loop. This computes it with a while loop. With the while loop, I had to add this to initialize the value. I had to add this to increment the value. So the while loop's more complicated, but the while loop is more general. Anything I can do with a for loop, I can also do with a while loop. So, common question. Why even have for loops? You can do everything with a while loop. Why not just have everything with a while loop and throw for loops out of the language? And the answer right here. The for loop is easier. I don't need this initialization statement. I don't need this hop count increment iterate statement. I can just do that. Okay. Let's go back to our old pal, the list of states. Okay. Let's read that in. Now, we know with a for loop, a for each loop, for state in states, print state. An easy loop to print out each state in the list once. That's the simplest thing I could do. Do the same thing with a for I loop. For I in range length of states -1, print states sub I. Python is case sensitive. Yes, indeed it is. There we go. equivalent loop to do the same thing. For each, for I. How would we do that in a while loop? Well, there's a bunch of different ways, but here is the easiest way to do it in a while loop. I equals 0. While I is less than length of states, print states, it's case sensitive again, sub I. Now remember, I have to iterate, I have to increment, I have to add 1 to I, or this is not going to work. So this is a way of doing the same thing with a while loop and a for loop, going back through our example. For each loop is the simplest case. That's it right there. That's the entire for each loop to go through a list and print out every state name once. A little bit more general, a little bit more complicated. For I had to give this range statement. I had to remember that I can't use length of states, and I had to print out the states of I. While loop, a little bit more general. I had to give an initial value. I had to do this Boolean. I had to think about what it was. I had to print it out, and I had to increment. Okay? So you can do everything. It's a little bit more complex. It's a little bit more general. It's a little bit more powerful. I said it's also a little bit more risky. Okay? Here is a case where I'm going to run this code, and let's see if this works. I need to just going to, let's do this way. I need I equals 0. And now in this, I'm just going to comment out this line so it doesn't get executed.
Professor?
And now I'm going to run my code.
Professor?
Yes, go ahead.
I wanted to ask, so what is, where are you using the I+1? I don't know.
Okay, so the reason is what I'm showing on the screen right now. And crap, what is the kill this sucker? Hang on. Yeah, it's Control Z, I think. Yeah, right. So what happened is, if you do not increment, it stays 1 all the time. The I stays 1. So let me get this under control. When I did that, when I ran that code, I said I equals 0. So I can start with Alabama. While I is less than length of states, print states sub I. Now, if I just tried to run this code, I is 0, 0 is less than 50, so it's going to print states sub 0, which is the first state, right? That's Alabama.
Yeah.
That's the end of the loop. It's going to come back up here. I is 0, 0 is less than 50, it's going to print state sub 0, which is Alabama. I is less than 50, it's 0. Print state sub 0, which is Alabama. And that's what I showed in the previous console, which is that it's what's called an infinite loop. It will never end. With the code that you see right here on the screen, I is 0, and then just this loop, the value of I never changes. There is no automatic hop count. There is nothing that can change. And this is what we call an infinite loop. It is a loop that will never end until someone outside the program forces it to end. Okay, it will run for, theoretically, it would run forever. And, you know, a million years from now, it'll still be running. So you've got to come in from outside and stop it. Okay. And so that's why the way I avoid this is I say I plus equals 1. This statement lets me go through the list elements one at a time and not have an infinite loop. Now, if you do get it in an infinite loop, and it's fairly common, if you do it on gl.umbc.edu, it will stop you after a while because it doesn't want you to hog the system resources and burn up everything that belongs to the college with your programming error. Right? Everybody does it. We all do it. I've done it unintentionally. Infinite loops are common. So it will stop it automatically for you. If you do it in PyCharm, we're going to have to figure out exactly what the stop the program is on an infinite loop. It's a command Q or a command Z or something like that. I'll have to go back and look. Okay. So the answer to your question as to why I do this is it prevents an infinite loop. In a for loop, I don't have to do this because a for loop increments the variable. It has a hop count. It changes a variable for me. A while loop is risky. You can get this infinite loop because you just don't change the value. So that's one of the things we mean when we say, you know, a while loop is more general, but it's more risky. You can get an infinite loop. An infinite loop is something that will never end because this Boolean will never become false. If this Boolean never becomes false, your loop will never end. Now, I think if I've copied it over, I've got an example of that. I want to print, here's another example. Let's run this. Okay. Get that out of the way. I want to print all the positive odd numbers that are less than 100. Okay. So start at 1 because 1 is the lowest positive odd number. Now, I'm just going to print the odd numbers. I'm going to add 2. I'm going to print 1. I'm going to print 3. I'm going to print 5. I'm going to print 7. I'm going to print 9. Here's the problem. I'm checking to see whether num is equal to 100. I want to stop when num gets to be 100. Why is that a problem? Num is going to be 1, 3, 5, 7, millions, billions, trillions. Num is never going to be exactly 100. How about that? Yes, I want to exit. Sorry about that. Let's go back to PyCharm. Num is never going to be exactly 100 in that because it's odd. It's 1, 3, 5, 7, 9. So this is an example of something that will happen to you a lot in your coding days. Again, it happens to me. What is my stopping condition? When do I terminate? I terminate, in this case, I try to terminate when num is exactly 100. But num is never going to be 100 because num is always going to be odd. Okay, num is always going to be odd. It's 1, 3, 5, 7, 9. So it's always 100. I mean, it's always not equal to 100. So this Boolean is always true. It's never false. That's an infinite loop.
Professor, your screen is gray. We can't really see anything.
Oh, okay. Probably kicked me out of sharing PyCharm. Give me a second. There we go. Okay, you got PyCharm back?
Yes.
Thank you. Cool. Okay, so this was the code I ran that caused the problem. I got the brilliant idea to stop when num is exactly equal to 100, and what happened? Num is never going to be equal to 100 because num is always going to be odd. And so this Boolean will never be false. It will always be true. And therefore, this is an infinite loop. So when you're writing a while loop, it's important to think about exactly what the stopping condition is. The stopping condition is something that you need to make sure you understand so the program will run the way you want it to. Now, so I've shown you a couple of infinite loops. Infinite loops are things that are, the variable never changes or it never takes on the right value or whatever. That Boolean condition never becomes false. That's an infinite loop. Here is a loop that never executes and that you probably didn't mean to. You probably didn't intend this. Okay. So here I'm asking the user to input age. I'm asking the user to input your age. And I'm only going to accept ages that are between 0 and 100 inclusive because I don't believe you're negative years old. And while I would be thrilled if you're using my program when you're over 100, bluntly, I don't believe you are. I mean, my father-in-law is 93. He's awesome. He's amazingly talented with a computer, but, there's limits here. So I want to make sure that your input is between 0 and 100 inclusive. Okay. Okay. Here's the thing. Let's look at this condition. While age is less than 0 or age is greater than 100. Okay. If you're, let's run this again. Okay. While age is less than 0, well, 9 is not less than 0 or greater than 100. 9 is not greater than 100, so that worked. Now let's try this. Negative 20. Okay. What did I mess up on? What I messed up on is this. The example is supposed to be an and. Okay. Because the same number cannot be less than 0 and greater than 100 at the same time. So here's an example of a condition I wrote where this loop will never execute because this cannot be less than 0 and greater than 100 at the same time. So syntactically, it's a perfectly valid loop. Semantically, this is incorrect because it will never execute, and that's not what I wanted. It's one thing if I write a loop that says this will never execute because the user input the right value the first time. That's good. This is something that doesn't work right because this could never have both values at the same time. So let's go back to the slides and make sure I'm covering what I'm supposed to be covering before I move on. Okay. So we're going to talk about while loops in general, which we've been doing, and then we're going to get into a couple of special loops that we need to talk about. The syntax, as we said, is right here. The word while, reserved word. Some Boolean condition, the loop is going to execute when that Boolean condition is true. Colon, and then again, indent, and anything that's indented is part of the loop. Now remember your indentation. Set an initial value for your Boolean condition. Unlike with for, you don't automatically get a new value for your new variable. examples. We covered this. Here, we set an initial value by assigning it. If we leave out this initial age, we ran that, you get an error. The program crashes because it doesn't know what age is. It can't evaluate this particular Boolean. Okay. How many times is this loop executed? We don't know. It's executed until the user cooperates. It's executed until the user inputs a meaningful value. Priming rate. Age is equal to int of input. Here is my priming rate example where I get it. The reason I do it this way rather than assign is with the assignment. This is guaranteed to execute at least once. Here, if the user inputs the right value the first time, loop never has to execute. We never have to print out an error message. That's great. Yeah, don't get an error message. I like that. Here is the while loop factorial. I wrote the factorial loop both as a for each and a for I. By comparison, you can do it. This is the most general solution. The while loop is the most general loop, but there's extra code. I've got to set this, and I've got to increment. Didn't have to do that in the for loop. Common program errors. The loop's never executed. Here's one that doesn't execute. Again, if the loop's never executed because the user inputs the right thing the first time and there's no error message to print, you're good. But think about that. You know, if in many cases, if the loop never executes, it's because you messed up something in this Boolean condition. Another loop that never executes, like I said, that's an error. This or is supposed to be an and. Fix that. Common errors, infinite loops. We talked about that. We demonstrated that. Here are several examples of infinite loops and why. Here's a case where I'm asking the user to input a grade, but my Boolean condition talked about what is the name, and the name is never going to get any value other than this initial empty string. So this is an infinite loop because I never change the initial value of this, and so this Boolean is always true. Okay. Here's a case where I made an arithmetic error. I started with 50 cookies. I'm going to eat one. You know, the Cookie Monster eats cookies. You start with 50, you eat one, but instead of subtracting a cookie, I add one. So cookies are never going to be less than or equal to 0. All the cookies will never be gone. When you eat a cookie, you get an extra one. You always have more than you started with, which is fun for a while. This is an infinite loop because this Boolean is never going to be false. I'm never going to get down below 0. And this was the example I showed. I started by printing the odd numbers. I made sure that num always has an odd value, and I said the loop will stop when it's equal to exactly 100, and it's never going to equal exactly 100. Now, a sentinel loop. So we want to cover sentinel loops, and we want to cover Boolean flags. Let's talk about a sentinel loop. Sometimes we're asking user to input data. Okay. So we're going to say, get more room in my edit file. We're going to ask the user to input classes taken this semester. Tell user to enter Q or capital Q. We're going to be nice to the user to quit. Here we go. Courses equal an empty list. Course equal input enter the next course, enter Q or Q to quit. While, now, I got to think about how I'm going to do this because otherwise I'm going to do it wrong. So, here is the condition. As long as the user has not input either a lowercase q or an uppercase Q, we're going to keep going. So, while next course is not equal to lowercase q and next course is not equal to uppercase q, that is my Boolean condition. The user did not enter a little q and the user did not enter an uppercase q. Now, there are any number of other ways I could have written this Boolean condition. I could have written, I'll comment it out. I could have said, let's use a comment so I don't get an error. I could have said, while not next course equal Q or next course equal capital Q. That's an equivalent Boolean statement. So that's what I mean when I say you've got a number of different ways to do this. And in terms of grading your assignments, if it comes out with the correct logical value, we accept it. You could do this. You could do that. That's equivalent. We accept either one. So at any rate, I need a tab. Okay. Courses dot append next course. So what I'm doing is I'm building a list of courses that the student is taking. And so now when the user enters, now I've got to get the next one input, right? Because nothing happens automatically. I'm going to have to prompt for the next one. So next course equals input, and I'm just going to copy this line right here because otherwise I'm going to make a typo and then I'll have to fix it. Okay. Yeah, okay. All righty. Now that's all I need from the loop. If I leave out this next course state, I'm in an infinite loop. Okay. So now I'm done with the loop. All I'll do right now is I'll just print out the courses that you're going to take. The classes you're taking this semester are courses. I won't bother making that fancy. This is what I'm going to do. So this is my sentinel loop. Enter the next course. Math 451. Physics 103. Stat 819. CMSC 291. Q. Okay. And then we print out, we end the loop when we hit the little Q, and we print out the values that have been typed up. So I've built the list. Now, why do I do it this way? Because I don't know how many courses you're taking. I mean, you may be a part-time student and CompSci 201's the only one. You may be a fully loaded full-time student and you may have 7 or 8 classes. Okay, I don't know that. So what I'm going to do is I'm going to write this sentinel loop and it's going to run until you enter a specific value. Now, in this case, the little q and the big Q are what we call the sentinels. Those are the things that we look for. Those are the things that say stop. Okay, either a little q or a big Q is a sentinel. We are going to run until we see something, and when we see something, we're going to stop. We're done. In this case, it's the little q and the big Q. So this is a sentinel while loop, and the sentinel values are these things that make it stop. Okay. Sentinel while loops are very important because they're used all the time in inputting data. If you don't know how much data, you don't know how many values are going to be input, the user is going to input data till you're done, then you have a sentinel at the end, because you can't say read 10 values, read the 5 classes you're taking, enter the 3 classes you're taking, or whatever. You read until you see the sentinel. The sentinel is the little or big Q, and then you say stop right there. So that is a sentinel loop. And it's very, very useful because that's how you allow the user to keep inputting data, however much or little it is, and stop when done. So that is a sentinel while loop. And I think, as I said, definition, it runs until a specific value is encountered, big Q or little q. The sentinel is the value that says this is the end of the data set, the little q or the big Q in the example we covered. And this is the description. This is the pseudocode for the example that we just went through. Okay. And here's a slightly different version of the same thing. We're asking the user to continue inputting everybody's birth dates. I want everybody's month and date, birth date, and I'm going to stop, in this case, only when I hit a big Q. Now, in this case, when you hit a little q, it's not going to stop, so you may need to think about that. But that's the same idea. It's just another example. Look for the sentinel. Pardon. The last type of loop, of while loop, we need to make sure we understand is what's called a Boolean flag loop. Now, this is confusing to a number of people, and I get it. It is. It's a weird terminology. A while loop is while Boolean condition. So we've got a Boolean condition in the while loop by definition. So what's a Boolean flag? The answer is it's a simplified case where our Boolean condition, instead of being some expression, is an explicit variable that I can set to true or to set to that or set to false. Now, let me see if I can zoom in to illustrate this. There we go. So, in this case, I have a prompt. I ask the user, in this case, I instead of putting the string literal in the input statement, I made it a variable. I ask the user to input something. I tell the user to enter quit. My Boolean is, while message is not equal to quit, print the message. Okay. So this is a while loop where my Boolean expression, my Boolean condition that stops the loop is an expression. It's variable not equal to specific value. This is not a Boolean flag loop because this is an expression that has to be evaluated. By comparison, a Boolean flag loop has only a single Boolean variable here. I initialize active to true. This is a Boolean variable. While this Boolean variable is true, execute, and then maybe I change it down here. I may change it to false. So a Boolean flag while loop, it's a style issue. Some people like it. It's fairly common. Some people like to use these a lot. A Boolean flag loop has this as a single Boolean variable. If this is a single variable, it's a Boolean flag. If it's an expression that has to be evaluated, it is not a Boolean flag. That is the terminology. Now, this is not as important as a sentinel loop. As I said, a sentinel loop is very common when you're inputting data and you don't know how much you're going to input. But a Boolean flag is a common way of writing things where this is just a single value and not an expression. So when we ask you about a Boolean flag loop, the answer is this is a single variable, which is called the flag, not an expression to be evaluated. Okay. So when we say Boolean flag while loop, now, why do you want a Boolean flag loop? Just because they're good. I mean, they're good things to use sometimes. You don't have to use them. It just, to some people, this is a simpler design. It's simpler to say while active, while, true, while whatever, execute. It's just a particular way of writing them, of writing while loops that lets you do some things. Okay. All right. So let's go back to regular size. Okay. So that is what you need to do everything in the lab that will be covered tomorrow. So when you go to your discussion section and talk to your TA, it should, if I've looked at everything carefully enough, and I think I have, it should be the case that nothing's going to be new. You've covered everything. We've had the while loops. We've talked about them. They're more general than for loops. You've seen, when this pops up in your lab and your homework, you've seen it. You know why you're doing it. You've seen for loops. This is homework 3, by the way. The homework, I believe, does not use while loops. The homework only uses for loops. So for each and for I, you can do the homework. Let's do next Monday. While loops, you can do the lab. They're more general. With power comes responsibility. We give you a more general loop that works in more situations and is more dangerous. It's easier to write an infinite loop. It's easier to write a loop that never executes. You have to remember to initialize the value in the Boolean condition. You have to remember to increment or change the value in the Boolean condition. Okay. With a for loop, you don't have to do anything of that. The initialization is set. With a for each, you just go through the list one at a time. With a for I, it's all set in that range statement. You have to, in the while loop, manually do that. You have to, as the programmer, it is the programmer's responsibility to do that instead of letting Python do that in for. So, good thing. We've talked about them in general. We've talked about them as the sentinel loops, which again are most commonly used when you're asking the user to enter data and you don't know how much data is going to be entered. So give me the sentinel when you want me to stop. And a Boolean flag is simply a case where that's a single Boolean variable rather than an expression to be evaluated. And that, I believe, let me check, is everything. And we're actually 5 minutes ahead of time. So if you have any questions, I'm happy to take them. If not, you can have 5 minutes extra back in your day to have some fun or maybe get some homework done. Any questions?
I have a question. So
Certainly, go ahead. Sorry, I muted myself. Sorry, go ahead.
You're good. So do you have any sort of advice on how to start the homework assignments? I find that I have a hard time starting the homework assignments.
I understand that, and so I think the easiest thing to do, to me. Remember, pseudocode is an English language description, so I find the thing to do is to look at the sample output we give you and sit down and think about what would it take to generate that.
Mm-hmm.
Okay, and then once I have an understanding of what it would take to generate that, then I can usually work backwards and with the pseudocode given in the assignment, plus the list of desired outputs, that's where I usually, I can start getting zeroed in. And that's what I say, it's not uncommon as we get more and more complex to start looking and go, how do I solve this big problem? Well, bite off a little bit, right? Figure out how I'm going to produce this particular output statement. Figure out how I'm going to produce that output statement. And then once you get a few lines working and it produces what you want, then I find it's easier to build and grow. Or if you get something and you think you know how to produce that output and it doesn't work right, then you need to fix it.
Right. Thank you.
Cool, no problem. Anybody else?
I also have a question.
Sure.
So this one is a little more technical.
Yep.
I'm having trouble submitting one of my homework assignments for homework 2. It's the third problem, the one where you got to make the gate. It's like I try to submit that one specifically on the Gmail server, and it doesn't turn it in for some reason.
Okay, and you've checked that you've spelled, there's not a typo, there's not a misspelling in the name?
Yep.
Okay, let me ping either Sean or Min, whichever's on duty. Sean is the head TA, Min usually runs that server. I'll ping the two of them and make sure that it's still open.
Okay. Awesome.
So, because it's when did you try? Let me ask that.
Yesterday.
Okay, cool. Yeah, see, they
not yesterday. It was 2 days ago. Yeah, it was Saturday.
Saturday. Right. See, what happens is they program the system to shut off at midnight for the majors, and every now and then they get swamped with work and they accidentally shut off ours too. And so let me talk to them and make sure that there's not an issue, that they didn't accidentally shut that off.
Okay, because I submitted like the circuit problem with the other 4 problems, and I was able to turn in the other 4 fine.
Right. That's like I said, my 2 immediate guesses would be there's a misspelling somewhere, or they accidentally shut that one off. I'll ask them just in case.
Okay, thank you.
If for some reason we can't get it submitted tonight, I can give you an extension on that in this case. So try later tonight. If we can get it fixed, we'll get it fixed. If we can't, I can give you an extension and get it in later.
Gotcha. Thank you.
Are you in Kevin's class or Mariah's?
Kev.
I'll let him know.
Okay.
I'll let Kevin know too, just in case. So, okay. All right. Any other questions? All right, cool. I will talk to you all on Wednesday. Enjoy your evening.